So in the last video, we talked about how the tangent plane is given by the z discrepancy is the slope in the x direction times the x discrepancy plus the slope in the y direction times the y discrepancy. And that the linear approximation is found just by, oops, let me replace that equals with an approximation sign there, is found by just taking that constant z naught term, interpreting it as the function value and putting it over on the other side. So talking about the planes a little bit more, I thought it might be good to sort of recap the general formula for a plane so you can see another way that this comes around. So the standard formula for a plane looks like this. And so in this setup, n is going to be the normal vector. So it's some vector that looks like this. And if our plane looks like this, then the normal vector n is the one that sticks out at a 90-degree angle like that. And so then P is our point that's moving around, and P naught is our point that's fixed, so our particular point. And so in this case, the base of this vector, that would point right there, would be our P naught. Okay, and then a general point P would be anything that's out here, satisfies the equation. All right, so if we look at n dot P naught displacement, this is the same thing as n dot oh, whoops, silly me, I put the 0 on the wrong one. There we go. So this is P minus P naught, or a B C dotted with, and then P minus P naught is X minus X naught, Y minus Y naught, Z minus Z naught. And so when you do the dot product, you match up the first coordinates, and then you match up the second coordinates, and then you match up the third coordinates, multiplying them together, and then you add everything up. Okay, and so if we reshuffle this a little bit here, so this is supposed to be equal to 0 by the definition of the original equation here. So for if we make a substitution here, if we divide through by c and we write a as minus a over c and little b as minus big B over c, then we can rewrite this equation as z minus z naught equal to a x minus x naught plus b y minus y naught. Okay, so this is the formula then for any plane. It's just rewritten in a slightly different way. Now for a tangent plane, we're looking specifically at the case when these slopes right here are going to be coming from the partial derivatives. And then that will make this into a tangent plane. So here's my favorite example. 4 minus x squared minus y squared. And so I've drawn in here in green the tangent plane x equals 1, and in blue the tangent plane y equals 1. And so this point right here is directly above, so this is the point 1, 1 in the xy plane. So actually it's 1, 1, 0. And this height right here of this line, that represents the function value. So the top right here is f of 1, 1, which is equal to 2, as it happens. And then let's see. So as we do the trace in the blue plane right here, so that we get this, whoops, shoot, it straightened my curve. Okay, so that's my parabola right there. Then we get a tangent line that looks like this. And if we look at the slice coming through the other way here, then we get a tangent line that looks like this. And the tangent plane is this little plane that touches exactly at that spot right there in the center.